Okay, next one I want to do is 2013, number 3. So this one is very similar to the one we just did from 2018. If you look at the 4 different questions that you are asked in this one. So, but let's just run through it again and show, and this kind of hammers home how similar the AP can be sometimes but again, notice the break in years. This was from 13 to 16. So 3 years later, they asked a similar question, not necessarily year to year. So the first thing they ask us to do is approximate C prime of 3.5. Okay, so again, it's asking you to estimate a derivative, which just means find a slope at some close points, which would be between the 3 and the 4, and do the slope between these 2 points. Okay, 2 points close to it, and here you just get 1.6, right? So units. So remember, when I subtracted the top, they told us that the C of T was in ounces, so that means we have ounces. They told us the time was in minutes, so I know I have ounces per minute. Again, they don't ask us to interpret like they did in the last problem, so that's just your answer, okay? All right, so the B part. Is there a time? So again, they varied the wording slightly, but it's still the same type of problem. Is there a time means theorem such that C prime equals 2. So again, I'm going from C to C prime, so this is going to be another case of MVT. So if I look at, they told me between 2 and 4, so that's the first thing I'm going to check. If I do the slope between 2 and 4, I do get 2. So these are the 2 endpoints. So sometimes they give us the endpoints, sometimes we have to search. Okay, so again, how do I know it meets the conditions? If you look back up in the given, they tell you that it is differentiable. Okay, so they have to tell you in a table problem. So since C of T is continuous and differentiable, again, remember, if it's differentiable, it's continuous. And, okay, so here's where it is. Show your slope. So it is going to be C of 4 minus C of 2 over 4 minus 2 equals 2, okay? Then MVT guarantees it. Guarantees C prime of T equals 2 in the interval 2 to 4. Again, same kind of wording, same type of problem. Okay, so part C is very similar to what they asked us for part C on the other one. This time they want us to do a midpoint Riemann sum. And what they're asking us to do is, so they're kind of reversing it how they did in the other problem. They're asking us to estimate this value using a midpoint Riemann sum and then interpret what it means. Use the units and explain the meaning of this. Okay, so again, it's still asking you to know something about what average means, okay? But in the previous problem, they asked you to find the average, so you had to know what to do. Here, they're giving us the formula for average, but that means we're just gonna have to cite it later as an average. So again, a Riemann sum estimates this part, just the integral. So I'm gonna have the 1/6 in front, and then I'm gonna estimate my midpoint Riemann sum. Now remember, with a midpoint Riemann sum, you're always going to have much more on the table than you need, because notice it says only 3 subintervals. So that means there's 3 rectangles. And again, but I have 7 things on the table. The reason being is, remember, for a midpoint Riemann sum, okay, you need a bigger width. So I actually have to skip a number. So my first rectangle goes from 0 to 2. And the reason why I have to skip a number is because the height I'm using is the one in the middle. So my second rectangle goes from 2 to 4, and I'm using this height. My third rectangle goes from 4 to 6, and I'm using this height, okay? Now, the one thing, and they usually do this in a midpoint one, is they give us an even table. So you'll notice the width of each rectangle is the same. It's 2 every time. Remember, the width goes from the beginning of the rectangle to the end of the rectangle. So from the 0 to the 2 to the 4 to the 6. All of those have a height. They all have the same width of 2. And then I have my 3 different heights, which are 5.3, 11.2, and 13.8. I am done there, right? That's it. I am done. Okay, I could leave it like that, or I could actually get the numerical answer. Again, you are going to have access to a calculator, so you can get the numerical answer now, and this one would be 10.1. Okay, now they want us to estimate the units, okay? So remember, it's average amount of coffee that we're finding. So the interpretation is, this is the average. Remember, always with this, and again, without the 1/6 in front, it's no longer average, okay? With the 1/6 in front, we're saying average. And remember, the interpretation is it's average, whatever we're integrating. So in this case, we're integrating C of T, which is the amount of coffee. So all I'm going to interpret it as the average amount of coffee. If C were the rate of coffee, it would be the average rate of coffee. Okay, so this is the average amount of coffee in. Now remember, average amount is still an amount. So however you measure the amount equation is how you measure the average amount equation. So in this case, it's still ounces. Again, since it's an integral, you also have to mention from 0 to 6. In this case, time is in minutes. Okay? So both part C's in both of these table problems were averages, but one of them said the word average, but you had to know what to do. The other one gave you the average, but you had to know that that was the average. So same kind of forwards and backwards knowledge. Now, the part D's are also similar because they give you, again, this gives you an equation for the amount of coffee, right? So they give you this B of T equation with the amount of coffee. Okay, so this is the amount of coffee in a cup. Using this model, find the rate at which the amount of coffee in the cup is changing when T equals 5. Well, so same kind of thing. I have to do a derivative. What's good about this one is I do not have to do this as a related rates problem. Why isn't this a related rates problem? Because my amount is already in terms of time. I don't need to bring time in. In the previous problem, our height of a tree was in terms of diameter. We wanted the rate of the height of the tree in terms of time. So we had to bring the time into the problem. The time is already here. So this is just a regular derivative problem. All I have to do on this one is just B prime of T, because when I take the derivative here, it's in terms of T. So all it is just the derivative of an E. So remember, the derivative of 16 is 0, and E, we repeat, times the derivative of the exponent. Sorry. That's all it is. And then we substitute in our time. Okay. And again, you do have access to a calculator, so you could go one step further and substitute in. So this would be 6.4 e to the negative 2, or you could write that as 6.4 over e squared, okay? And they do want units on this one, so again, the units here is change in y over change in x, so this is amount and time, so this is ounces per minute. Okay, again, you do have access to a calculator. This one was question number 3 on the AP it was on, which technically is a no calculator one, which is why all this derivative work was necessary by hand. But remember, if it's just a straight derivative, you could also use your derivative button to get this as a decimal. It'll just give it to you as a decimal and you round it to 3 decimal places. This one was technically designed to be a non-calc question, but if it's just a straight derivative, remember you could also use the derivative button on your calculator. Okay, so a little similar, some variations, but the types of questions were the same on this one. Okay.